Welcome guys, this is VT engineering tutorial and we are still under deflection of beam and we'll be continuing with what cantilever beam. And today we'll be looking at what case 2, which is what a cantilever beam carrying a concentrated load W at a distance A from fixed end. Look at this diagram that I've drawn here. So let me explain the diagram for you so you can understand what you are really doing here. If you look at this diagram very well, you can see that at point A it is fixed. And at point B, it is what? It is at a free end. This is what they call a cantilever beam. When a beam is fixed at one end and at the other end, it is free. So L is what? The total length of what? Of the beam. And if you look at this case 2, they told us that our load W is what? At a distance A from the fixed end. So this is the distance at which the load is what? Is placed on the cantilever beam. So I name the point as what? My point C. If you look at the beam very well, you can see that since N is what? The total length of the beam, and A is what? The distance between what? The fixed end and what? And where the load is placed. So for us to know the deflection at any section of this beam now, we need to consider any section. You can decide to consider this section if you wish, but me, I'm choosing to consider this section, which is what? At a distance X from what? From the fixed end. So now, for me considering this section now, at section XX, I need to find my moment at this point now. So for me, we know that moment is what? Force times what? Perpendicular distance. And if you can see that at this fixed end part, there is no force here. So the force that is placed on this beam is what? The W, which is what? Which is acting at what? At point C. So for me to get my section, which is what? My moment at this XX now, I'm going to have my NX, which is what? Moment at what? Section XX equals to what? So but you can decide to use coordinates. Maybe like this, I'm considering my upward force to be what? Positive, and my downward force to be what? Negative. And sometimes you can decide to use clockwise what? And anti-clockwise to determine your what? The direction of your what? Of your forces. So if I'm considering this coordinate now, I've told you guys that my upward force should be what? Should be carrying positive, and my downward force should be carrying negative. So in this case now, the weight that is put on this cantilever beam is what? Is acting what? Downward. So my downward force here, which is what? W is what? Will be carrying what? Negative. So I'm going to have what? Minus what? W, which is my force. So you understand that moment, I'm looking for moment. For moment is what? Force times what? Perpendicular distance. And don't forget that I'm considering this section now. This is my force, and my perpendicular distance is what? Is moving in this direction to what? X. So the distance covered from here to here is what? A minus X, because from here to here is what? A. And I've told you guys that from this point to this point is what? X. So definitely for me to get this point is what? A minus X. So it's covering what? A minus X. So this is my moment at what? At this section what? X. But don't forget that we have already established that moment equals to what? EI the square y over the x square in relationship between slope, deflection, and radius of curvature. So since moment is what? Minus W A minus X, and moment is also EI the square y over the S square. Definitely EI the square y over the S square is equal to minus W A minus X. So in this case now, I hope you understand. So we are now having what? Our moment to be what? EI the square y over the x square equals to what? Minus W A minus X. So this one now is what? Is equal to this one now. So let me write it. Therefore, EI the square y over the x square equals to what? Minus W A minus X. And let me label this one my what? Equation 1. I hope you understand how we get to this point now. So the next thing for us to do is that to integrate this equation. So when we integrate this equation, we are going to have what? Our equation for slope, and we are going to use that one to derive what? Maximum slope at this point where the load is what? Is placed. So for us integrating this equation with respect to S now, so we are going to have what? So now integrating equation 1 with respect to S now, as you can see that this one like this, the square y over the x square is what? The second order of what? Integration. So now, the second order of what? The differentiation. So by integrating this one, I'm going to have what? ei dy dx equals to what? Minus w. A is what? A constant. By integrating a constant, I'm going to have what? A variable x, since I'm integrating with what? With respect to x. So I'm going to have what? Ax minus, but don't forget this one is already a variable, which is what? X. So by integrating this one, don't forget that there is an invisible one here. So by integrating it, I'm going to have what? S squared over what? Over 2 plus what? C1. Which is what? C1 is what? Our constant what? Of integration. So by finding my C1 now, I need to find the value of my C1 now. If I find the value of my C1 and I input it into this equation, I'm going to have what? Equation for slope at what? At this point C. So now, my C1 now, my C1 now is what? First constant of integration obtained when x equals to 0 and the y equals to 0. So if you look at this very well, you can see that my C1 what is obtained at what? At this fixed point. So at this fixed point now, my x is what? The distance of my x is what? 0. And my dy dx equals to 0. Don't forget that dy dx what is used to represent slope. And at this point now, I don't have what? I don't have slope. So definitely, since I don't have slope at this point now, my C2, my C1 will be equal to what? 0. At this fixed end, my C1 is going to be equal to 0. So now what I'm going to do next is what? To substitute C1, which is 0, into this equation and to have what? My equation for slope. So by substituting this value into this equation now, I'm going to have what? Ei dy dx equals to what? Minus w ax minus what? S squared over 2. So now, this one is what? Equation for slope. So now, this is my equation 2, and it's the required equation for slope at any section of what? Of this beam now. So this equation now is my what? My equation for slope now. Don't forget this one is what? Is minimum. So for me to have maximum slope, my maximum slope now, or for me to have slope at what? At this point C. This one at the free end. You understand? But at where the load is placed, for me to have slope at this point C now, so I'm going to have what? That is what? When my x is what? When my x is equal to what? A. So I'm going to have my maximum slope here when my x, the value of my x is equal to what? The distance covered, which is what? A. So maximum slope my slope at C occurs when the section of my x is equal to what? A. So in this case now, anywhere I see x, I'm going to substitute A into this equation to have my maximum slope at what? At this point what? Point C. So in this case now, into this equation I'm going to substitute what? When x equals to A. So I'm going to have what? Ei dy over dx equals to what? So now my x is what? My x equals to A. So here I have negative what? Negative w. Don't forget that my x equals to A. So I'm going to have A here. A multiplied by A is going to give me what? A square. A square minus what? Here I'm going to have what? A square over what? Over 2. So I'm having A square over 2. Don't forget that this equation now, I've been taught to this equation when x is equal to A at what? At point C. So in this case now, I hope you understand to this level. So in this case now, what we are going to do next was to find the LCM of this one. You understand that? So by finding the LCM, we are going to have what? 2 here, don't forget. So 1. So 1 in 2 is what? We are going to have 2A square minus A square equals to what? This one is going to give us what? A square over what? Over 2. So now don't forget, this bracket now is what? So this equation, this bracket now has already given us what? A square over 2 multiplied by W, then we are going to have what? Our Ei dy dx equals to what? Minus W multiplied by A square over 2 is going to be what? Minus W A square over 2. So now, don't forget that dy dx is what? Our slope. So now, for our slope at this point now, which is what? Point C, we are going to have what now? Our slope at point C, which is the same thing as what? Our dy dx equals to, so for us to have dy dx here, we are going to divide both sides by what? By Ei, which is what? Our lecturer we did it here. So by dividing both sides by EI, we are going to have what? Minus WA squared over 2EI. So now we are going to have minus WA squared over 2EI. So this equation now is what? Equation for slope at what? This equation now is what? Our equation for slope at C. So now we have already find the equation for what? Maximum equation for our slope at what? At C. So in this case now, what next for us is what? To find the deflection at point C, at point D, and any section of the beam. So for us finding deflection at any section of this beam now, we are going to integrate the slope equation for us to continue our calculation. So integrating the slope equation. So now, by integrating equation 2 now, we are going to continue our calculation. So integrating this one now is what? First order of what? Of differentiation. So by integrating this one now, we are going to have what? EIY, which is I've already integrated that part now. So we made the second part, which is what? Minus W. So here I have an invisible one here. By integrating this one now, I'm going to have what? AX squared over 2 minus what? Here is already, the power is what? 2. By integrating this one, I'm going to have what? X cube. Then the power is going to multiply the denominator. So I'm going to have what? 6 here plus what? C2, which is what? Second. So our C2 now, let me name this one what? Our equation 3. So for us to find our constant C2 now, C2 is obtained what? At 3n when x equal to 0 and what? Y equal to 0. So C2 now equals to what? Our C2 is obtained when x equal to 0 and y equal to 0. So at this fixed end, our C2 is obtained, and at this point, the section x is what? Is equal to 0, and we don't have y here, so our y is what? Equals to 0. Definitely, if x equal to 0 and y equal to 0, in this equation now, so my C2 is going to be 0, because anywhere I see y now, I'm going to put what? Is 0. So definitely all this one like this will be equal to 0, and anywhere I see x, I'm going to put 0. Definitely this bracket will be equal to 0, then 0 multiplied by w is going to be what? Equal to 0. So my C2 definitely, C2 is going to be what? Equals to what? 0. So the next thing for me, since my C2 is going to be equal to 0, the next thing for me to do is to add this 0 with this whole equation, which is going to give me what? The old equation back. So now I know that the value of my C2 is equal to 0. What remains for me is that to add a 0 to this equation. Now if I add 0 to this equation, I'm going to have this equation back, which is what? EIY equals to what? That equation is what? Minus W. I'm going to have what? AX squared over 2 minus what? A minus what? Minus x. Sorry. Here I'm having what? X cubed over what? Over 6. So the next thing for me is what? To simplify this equation. So by simplifying this equation now, so this equation now is what? Equation for what? For deflection at what? At point C. So let me write it. Equation is what? Our equation for what? For deflection at what? At point C. So for me to have maximum deflection at point C, at this point now, for me to have my maximum deflection at what? At point C now. So YC now is obtained. So now for me to have deflection at this point now is what? When the section x is equal to the distance at where the load is placed. That is what? When x is equal to what? A. So when x equals to A in this equation, I'm going to have what? My maximum deflection, which is what? YC. So putting x equal to A into this equation, I'm going to have what? EIY equals to what? Minus W. Here my x is going to be what? A. So A squared multiplied by A is going to give me what? A cube over what? Over 2 minus, at this point now I'm going to have what? A cube over what? Over 6. So now this is what I'm with me with. I hope you guys understand and you are following me. So what I'm going to do next is what to exterminate this bracket. So by exterminating this bracket now, here I'm going to have what 6. This one like this is going to be what 2 in 6 is what 3. Then 3 multiplied by a cube is what 3a cube minus here is what 6. 6 is what 1. Then multiplied by this one is going to give me what a cube. This is going to give me what 2a cube over what over 6. Then 2a1 2 in 6 is going to give me what 3, which will mean what a cube over 3. Don't forget that it is this bracket that give me a cube over 3, but I still have what my negative w here. So now what I'm going to do next was my negative w minus a cube over 3 is going to give me what negative a cube over 3, which is going to give me what eiy. So now, so my eiy means negative w multiplied by what a cube over 3, which is what eiy equals to what negative w multiplied by what a cube over what over 3. But don't forget that this is what at point C. So my y now, which is what my deflection at that point now, is what yc, because it is what at point C. So now I'm going to divide both sides by ei. So it's going to remain yc only here, which is what minus w a cube over what 3 ei. This was equation. So this equation is what equation for deflection at point C. But if you can look at this diagram very well, you can see that at point C, that is not where we have what our maximum deflection. This is where our maximum deflection is. So now this is where we have what our this is what our yc, which is what deflection here. So but don't forget that yc is the same thing as what bd. So now we have what c and c prime, which is what c prime equals to what bd. C prime equals to what bd, and what cd is the same thing as what cb, and cd equals to what cb. So now by looking at this very well now, you can see that our deflection at C is what is from C to C prime now. We have already have that, which is what minus WA cube over 3EI, and it's the same thing with what BD. So now and our maximum deflection now is from where? From this point to this point. So we need to find our maximum Y max. Our y maximum is what from this point to this point. So now, but the deflection that we find is what from here to here, which is what from here to here. So we need to have to find our what b prime and d. So for us to find our b prime and d now, we are going to have what, since this one is what a similar triangle now, so we are going to have what tan TC equals to what. So now for us to find the tan of this angle now, but don't forget that this is the opposite of the angle, and this is what this is the adjacent. So and tan is what opposite over adjacent. So we are going to have what b prime d over what c prime d, because this is what this is the adjacent c prime d. So what you are looking for is that you are looking for b prime d. So to add with this one to get our what our maximum deflection. So by cross multiplying this one now, I'm going to have what b prime d equals to what tan c prime d. So I've already cross multiplied it. This is what I do here. I make cross multiply. So now, but in this case now, since the value of what of our theta c, that is what maximum deflection at c is very small. Therefore, since the value of what of theta c, which is what deflection at this point, is very small now. So now our tan theta c will be equals to what theta c, since the value is very small. So now what you are going to have left here is what b prime d equals to what this one now is what theta c, and this one is what c prime d. So now for us to have our theta c now, our theta c is what our deflection at what at this point, which is what our yc. So now our b prime d now is going to be what our deflection at this point now is what minus wa cube over 3ei minus wa cube over what 3ei. So now but remain our what c D, which is what? C prime what? D. So we need to know our CD now. But don't forget that the total length of this beam is what? L. And from here to here is what? A. So for me to get the remaining part here now, I'm going to have what? I'm going to have what? L minus A, which is what? The remaining distance here. So now from my C prime to D prime is what? L minus A. So which is what? C prime to D prime is going to be given what? L minus A. So now this is the deflection at this point of the beam. So now, so for me to have my maximum deflection now, which is what? B prime D. So maximum deflection. So now my maximum deflection is what? From B prime towards B. So I'm going to have what? B prime to B. This is what my maximum deflection is going to be what? B D plus what? D B prime. So I'm going to have what? Equals to what? B D plus what? B prime what? D plus B prime D. So now my BD. So my BD is what? My BD is the same thing as what? My YC. You understand? My BD is the same thing as what? My YC. That is what? Deflection at this point. At point C is the same thing. It's the same deflection now. So which is what? Minus WA cube over 3EI equals to what? Minus WA cube over 3EI, which is what? My BD, then plus B prime D. B prime D is what? This is my B prime D minus WA cube over 3EI L minus A. So now, sorry guys, there is a small mistake here. You can see that this is what? This is our what? Slope at what? At point C. And if you look at the maximum equation for slope at point C is what? Minus WA square over what? Over 2EI. So in this case now, here we're supposed to have what? Minus WA square over what? Over what? 2EI. So L minus A is what? C prime D. This is what? C prime what? Prime D. So for us to have our maximum deflection now, you know that this what is what? B prime D. So now for our maximum deflection, this was B prime and B. So now we have B prime and B now. So we are going to add B plus D and what? D plus B prime. So our B plus D now is what? Our B plus D now, if you look at it, our B plus D now is what? Maximum deflection at what? At this point, which is going to give us what? Minus WA key over 3EI. This is what? Our B plus D. So now this is our BD. So our B prime D, which is here, is what? Is to add. So we are going to have what? Minus WA square over 2EI L minus A. So one of them we have negative and negative here, which is what? Our Y maximum. So B prime B is what? Y maximum. B prime B. So we have what? Y max. So now my Y maximum at this point, which is what? B prime now, is going to give me what? B prime, which is what? My Y max is going to give me what? This one is what? Downward. You understand? So this negative means that it is going, the deflection is what? Downward. So we have what? WA cube over what? 3EI plus WA square over 2EI L minus A. So this equation now is the equation for maximum slope at any section of what? Of this beam. Thank you very much for watching our video. Please subscribe.